Alrighty, so if we take a look at the periodic table, we're gonna look for H or F, H, and C. So let's start with F. Okay, F is all the way over here, and we gotta draw its Lewis structure. Now, Lewis structure, we only draw the valence electrons, so the outside one. So it's super simple. We just need to count the boxes. So 1, 2, 3, 4, 5, 6, 7. So fluorine has 7 valence electrons, so we just need to put 7 dots around it. So if you guys got that, great work. You are in good shape for today. Okay. All right, let's do carbon now. So carbon is right here. So how many dots should I draw around carbon? 4, perfect. Super easy. And then hydrogen is right here. And so how many dots should be around hydrogen? 1, easy peasy. All right, so that's the warm up. That's what we covered last time, how to draw Lewis structures. Again, all you need to do is count the boxes, and then you just need to draw the dots for the valence electrons. Only thing I do want to mention is that we skip groups 3 through 12, so we don't draw these guys. So if you're going to do bromine, bromine is still going to be box number 7 because we ignore these guys. So if you wanted to draw bromine, you would do 7 dots around it. Okay. Any questions about the warm-up? Okay. So that part's pretty easy, but now what we're going to start doing is we're going to start combining these atoms together. So yesterday or last time we just drew pictures of single atoms, but now we're going to do molecules where you start combining these atoms together, okay? Alrighty, so make sure you guys write this part down right here, these 2 things, because they're important. So basically the reason why atoms form molecules is because they want complete outside or valence shells. Okay, they want to make sure that they are complete on the outside, okay? So atoms want to have complete valence or outside shells. So what that means is, if you guys remember, the first row has 2 boxes, right? So that means that the first shell wants to have 2 electrons. Okay, second shell wants to have 8 because there are 8 boxes. And then the third shell wants to have 8 because it has 8 boxes. We learned about that last time, right? That's the maximum number of electrons that can be held. So what that means is that every atom wants to fill up that outside shell. If the outside shell is shell number 2, it wants to have 8 in the outside shell. If it's shell number 1, it wants to have 2, okay? And so they do this by forming something called covalent bonds. And what that means is that they share electrons with other atoms, okay? So that's kind of the basic information. And then all we're gonna do now is do practice problems, okay? Okay, so let's take a look at Cl2. So if you take a look at this molecule, what is Cl2 made out of? What atoms are inside Cl2? Yeah, chlorine, right? Yeah, I'm trying to, yeah, it's for real. I'm not sure, I'm tricky, guys. So it's chlorine, which is Cl, and how many Cls are there? There's 2 of them, okay, for sure. Thought I lost you guys there for a second. So Cl2 is made out of 2 chlorine atoms, right? Okay, so if we take a look at Cl on the periodic table, how many valence electrons does Cl have? Cl is right here. How many valence electrons does it have? So 1, 2, 3, 4, 5, 6, 7. Yeah, 7. I'm sorry, I'm just too used to ignoring you. My bad. Yeah, so it has 7 valence electrons. So if we wanted to draw the Lewis structures of chlorine, we're just going to draw 7 electrons around it. Okay, so 1, 2, 3, 4, 5, 6, 7. And then we're going to do the same thing with this guy. 1, 2, 3, 4, 5, 6, 7. Okay, so both of these guys have 7 valence electrons. So far, so good, guys? Haven't lost you guys yet? Okay, now, if you guys take a look at chlorine, let's just look at one of them. One chlorine has 7 valence electrons, but how many electrons does it need to fill up that outside shell? Yeah, it needs 8, because if you take a look at the periodic table, chlorine is in the 3rd row. How many boxes are in the 3rd row? It's 8. So what that means is chlorine is going to want to have 8 electrons. So I'm going to just jot that down. So chlorine, they both want 8 valence electrons. Okay, it has 7, but it wants 8. And the reason why is because the third row has 8 boxes. Alrighty, so what they're gonna do is they're gonna form something called a covalent bond. And so what they're gonna do is they're gonna get really, really close to one another so that they can share electrons. So you guys don't need to draw this part, but if I was going to kind of represent this, we're gonna draw the 7 electrons for this guy, and then the 7 electrons for this guy. But they're gonna get so close, so it's almost like they each have 8. They're gonna share the electron that's in the, just on the side by itself, and they're gonna get really, really close. So it's almost like they're sharing. So if I cross out the one on the right side, it's gonna have 8 electrons. And if I cross out the one on the left side, it's gonna have 8 electrons. They're basically sharing these 2 electrons right here. Does that make sense? Okay, and so that's what a covalent bond is. But instead of drawing all of these, these electrons in the middle, instead what we do is we just represent that with a line. Okay, and there you go. This is going to be a picture of Cl2. This is what Cl2 looks like. Yeah. Yeah, this is what you're going to be doing for your assignment. You're just going to be drawing these structures right here. Okay, so this one's an easy one. Some of the ones on the assignment are, I'll be honest, a little bit difficult, but it's this basic concept. Okay. And so all you need to do is figure out how the electrons share, and you just draw a line to represent that. Okay. Any questions about that one? Or are you guys all right? Make sense? Okay, so the key thing to recognize is when you guys take a look at this element right here, let's look at the Cl on the left side. If I ignore the one that it's connected to, it has 8 electrons. 1, 2, 3, 4, 5, 6. And then this line right here, you might want to jot this down. One line is going to equal 2 electrons. So it's going to have 8. And then if we crossed out the one on the left side, it has 8. 1, 2, 3, 4, 5, 6, 7, 8. A line is going to represent 2 electrons. Any questions before we move on? We're going to do a couple that are a little bit trickier. Okay, let us move on. So there are a couple rules that I want to give you guys that'll help you guys out as we do the problems. Okay, so this tendency, if you guys notice, a lot of the elements want to have 8 valence electrons. Okay, and so make sure you guys write this down. It's called the Octet Rule. And basically, atoms, they want to have 8 valence electrons, okay? The only exception that we're going to run into in this class is hydrogen. Hydrogen wants to hold 2. Everybody else is going to want 8, okay? So hydrogen can only have 2 electrons, and it's because it's really small, and everybody else wants to have 8 valence electrons. And so as you guys are drawing your structures, these are the 4 tips that I want to give you guys. This is posted on Canvas, so you guys don't need to jot this down. But this is something that you're going to want to keep in mind as you're doing the problems. But whenever you are drawing a molecule, always put hydrogens on the outside. Carbon and silicon, Si, they go in the middle. More electronegative elements, basically the ones that are on the top right. So things like oxygen, chlorine, fluorine, things like that, they go on the outside. And then again, one line is 2 electrons outside of the structure. So right now we only have pairs, but eventually there's like a lot of atoms. And so hydrogens kind of go on the outside. Carbons are going to go in the middle. You'll see what I mean. Okay. So again, don't feel pressure to copy this down. It'll be on Canvas for you guys. And I'll be kind of guiding you guys through this with a couple practice problems before you do your assignment, okay? But these rules will really help you guys out. Some of the structures we do later on in the unit will get more complicated. But those are the ones you guys want to learn about, like cocaine and meth and heroin and THC and Why are you smiling so much, dude? You guys can't make it. You can't even do stoichiometry. Okay, let's do a couple of practice problems. Okay, so we're gonna draw a picture of Br2, and we want to figure out. Well, we'll get to this part later. So let's draw a picture of Br2. So what we're gonna do is figure out what elements are inside of Br2. What are the elements inside Br2? Yeah, bromine. How many are there? 2. So I'm gonna just draw Br and Br. Next thing you're gonna do is you're gonna count up all the valence electrons. So if you guys take a look at the periodic table, how many valence? Yes, Br is gonna have 7 valence electrons. And since there's 2 of them, we multiply that by 2. So how many total electrons are we working with? Yeah, 14. Good. So that's step 1. Step 1 is you're gonna count up all the valence electrons, which we did right here. Okay, so we're gonna be working with 14 electrons. And if this is a little confusing, bear with me, at least for the first problem. It'll make sense as we go through some more, okay? All right, next thing we're gonna do is we're gonna make sure that every single atom is connected with something. So there's only 2 of them, so we only need to make 1 connection, right? So we make a connection. So if you guys remember, how many electrons does one line represent? 2, right? So we use 2 of them to connect it. So let's take away 2. So how many electrons do I have left over? 12. Okay, so we connected them, and that's why we have 12 left. All right, and we want to make sure everybody has 8 valence electrons. So to make sure everybody has 8, we need to know how many each one has right now. So if we look at this Br, it's going to have 2 electrons because it's connected with a line, right? This is 2 electrons. So this has 2, but we want to get it to 8. So 3, 4, 5, 6, 7, 8. So that's going to be 8 electrons. Okay, we just want to make sure that every element ends up with 8. Okay. So how many electrons did we add to the picture right here? 6, right? Because we added 1, 2, 3, 4, 5, 6. So we used 6. So how many do we have left? 6. And very easy, because this guy needs 6 to get to 8. And there you go. That is going to be your picture of Br2. Okay. So all we need to do is use up all the electrons, make sure everybody is connected, and just make sure everybody has 8. We didn't have a hydrogen here, but hydrogen wants 2. Okay. So that's your picture of Br2. Okay. And we use 6, so this is going to be 0. All righty. Guys ready to try one that's a little bit trickier? Yeah? Okay. No? Too bad. Okay, let's move on to H2o, water. Okay, so first, if you guys think you could try this out on your own, go ahead. Oh, actually, I forgot one thing. We have to count the lone pairs and stuff. Okay, so this part's really easy. The second part, shared electrons basically means how many electrons are inside of these lines. So if there is one line, how many electrons are shared? 2. Yeah, it's 2 shared electrons. Because remember, every single line is 2 electrons. Okay, and this term right here, lone pair, means just things that are not inside of a connection. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's going to be 12 lone pairs. Okay, so any electron that's not inside of a line is going to be a lone pair electron. Okay, and that's the final answer. You are smart. Oh, never mind. Take it back. Take it back. All right, let's move on to water. Water is a little bit trickier. And again, if you guys think you could try it on your own, go ahead and do so. But I'll take it step by step since it is still new. So if we take a look at water, H2O, what's one of the elements inside of H2O? Yeah, we got hydrogen. How many hydrogens do we have? 2. And then we have oxygen, right? So we said in the rules that we want hydrogen kind of on the outside, right? So we're going to put 2 hydrogens And then we'll put oxygen kind of in the middle because, again, we want to put hydrogens on the outside. So that was one of the rules. So put hydrogen on the outside. Okay, which means that oxygen probably has to go on the inside. Okay, let's count the valence electrons. So if we go to the periodic table and we look at hydrogen, how many valence electrons does hydrogen have? Yeah, it has 1. It's the first box, right? So hydrogen has 1. And if we look at oxygen, how many valence electrons does oxygen have? 6. So that means we can count them up. So hydrogen has 1, but there's 2 of them. So 1 plus 1. And we said oxygen has 6. So 1 plus 1 plus 6 is 8. Yeah, 8 valence electrons. Okay, so that's going to be step 1. Count all of the valence electrons. Okay, next thing we're going to do is we're going to connect all the atoms. So everybody needs to be connected to somebody. So we're going to connect this hydrogen with oxygen and this hydrogen with this oxygen. Just make sure that everybody's connected. Thank you. So we're going to connect all the atoms. So we're going to connect the hydrogens with the oxygens. Okay, let's count up how many electrons we have left. How many electrons did we use to make these connections? 4, yeah. It's 2 lines. Each one of them is 2. So we used 4. So how many electrons do we have left over? 4. Okay. And then last step, we want to make sure everybody has 8 except for hydrogen. Make sure they have 2. So if you look at this hydrogen right here, how many electrons does it have right now? 2, yeah, because it's connected to a line. So this guy has 2, so he's happy. This guy has 2, so he's also happy. But oxygen has 4, so it's not happy. So what we're going to do is we're going to add 1, 2, 3, 4, and there you go. We got water because oxygen now has 8. There's 2 that come from here, 2 that come from here, 1, 2, 3, 4, and then that's going to be 8. Yeah. Exactly, yeah. Hydrogen only wants 2. Okay, so this is your picture of water. This is what a water molecule looks like. Okay, and then let's do the shared. How many shared electrons are there? 4? Yeah, there's 4 because there's 2 here, 2 here. So 4 shared. And then there are 4 lone pairs, and they're all on the oxygen. That's it. That's pretty much how you solve these out. Yeah, H cannot have any dots because it can only hold that line. So it can only hold max 2. That. Yeah, line counts as electrons that it's sharing. Yeah. H is it's weird because it's so small. I know how he feels. Okay, let's move on to the next one. Okay, so I'll give you guys about 3 minutes to try this one on your own. Okay, you're gonna draw the structure of CH4. Okay, CH4. A little bit more complicated, but make sure that you guys remember the rules that we talked about. If you guys need them right here, I can jot them down. But H goes on the outside. Okay, C and Si go in the middle. And then electronegative atoms go outside. Okay. And then one line, God bless you, equals 2 electrons. Okay, so take about 4 minutes. You can work with the person next to you. See if you can get the picture of CH4. Okay, so CH4 is pretty simple. If you guys take a look at the periodic table, you should notice that carbon has 4 valence electrons and hydrogen has 1. So since there's 4 hydrogens, it'll be 4 plus 4, and you'll have 8 electrons to work with, okay? Now, we said that carbon is in the middle and hydrogen goes on the outside. So we'll just kind of spread out the hydrogen so it's nice to look at. So we'll put the hydrogens around it. If you did it in like an X formation or they're kind of in one line, that's fine as well. Just make sure that the carbon is on the inside and hydrogens are somewhat on the outside. Again, pictures might look a little bit different, but as long as you get the general idea, it's okay. All right. Hey guys, can you guys go to your seats? Thank you. All right, so next thing we got to do after we count up all the valence electrons is we're going to connect all the atoms. So just make sure everybody has a connection. So everybody connects to hydrogen or carbon because the H's can't connect to each other. And so if you guys notice, we used up all of the all the electrons. There's 2, 4, 6, 8. So now we have 0 and everybody's happy. And that's it. Okay. Now, one thing I do want to mention is the reason you can't do something like this is because if you connect the hydrogens with each other, they can't connect with the carbon anymore. And so they're not one molecule. And so that kind of defeats the purpose of them being together. So that's the reason why we couldn't connect any hydrogens with each other. They have to connect with carbon because they can't hold any other elements other than 2. Okay. Do you have a question? Easy peasy. All right. Last one, and then I'll get you guys started on the assignment. And this one will be helpful for some of the bigger molecules that we see going forward. Okay. Okay, so sometimes you'll see things that look like this: CH3, CH2, CH3. Now, if you guys notice, usually we combine all of the elements together, right? So you see something like this. You see like C3H8, right? But if you guys notice here, everything is spread out, right? The C's are separated from each other and the H's are kind of separated from each other. Okay, what this indicates to you is that they're kind of in these sections. So these 3 are going to be together. These are going to be together and these are going to be together. So that kind of gives us a way to spread out the molecule. It kind of shows us what the molecule is going to look like inside of the formula. So what we're going to do is we're going to start just kind of by spreading everything out. So CH3 is going to be together. We're going to put C in the middle. We said the H's go on the outside, so we put them on the outside. That's going to be this part right here. CH2, we know that they're going to be somewhat together. C is on the inside. H kind of goes on the outside, so we put them outside like that. And then the last CH3 is together, and so C in the middle, H on the outside. Okay. Does that make sense? If it's spread out like that, it just means that's how they're kind of spread out in the structure. Okay. And I did a different color so you guys can kind of see where each part is. Okay, let's count up the electrons. So if you take a look at it, there are 3 carbons. And so each one of them is 4, so that's 12 plus 3 from that hydrogen, 2 from that one, and then 3 from this guy right here. And then we can get that to a grand total of 20 valence electrons. Okay, so far so good? Okay, so even though this looks really complicated, it's really easy. Because once you spread them out like this, just make sure everybody's connected. The H's have to connect with the carbons, right? And then these carbons need to connect with each other because there's no one else to connect with. So we connect the carbons. This guy's happy now because he has 2, 4, 6, 8. This guy has 2, 4, 6. So we just connect it with each other, gives it the 8. And this guy has 8. And if you count them all up, you got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And so everybody has 8, hydrogen has 2, and they're all connected. So that's it. That's how you would do that structure. Okay, so if this is still a little bit complicated, it's okay. This is kind of a weird concept, but this is how you draw the picture of molecules. You'll have a couple like this on your assignments. Just make sure that you guys refer back to it, okay? And in terms of shared electrons, everybody is inside a bond. So we got 20 shared. And then in terms of the lone pairs, there's no dots by itself, so there are 0 lone pairs. Okay. Alrighty, so I'll give you guys the rest of the class period to finish up the assignments. Some of them are a little bit long, and you do need to show your work in terms of, and what I mean by that is you need to tell me how many electrons there are and things like that. But I'll give you the rest of the class period to work. Let me know if you have any questions, you want me to go over anything, or if you want to check the answer key, okay? But good luck, guys.